Okay, integers are like whole numbers and their opposites, so including negatives. So which of these integers is not a whole number? Well, all of the negatives. So negative b is an integer, but not a whole number. Negative 3.5 is not an integer. It's not a whole number either, but it's not an integer. Okay, simplify. So first, just looking at the a's, we have a to the 6 up top, a squared on bottom. So looking at how they cancel out, I see I've got 4 a's left over. Okay, now working on the b's, I've got b to the 4th to start. And then I get 3 more b's. So in total, now I have 7 b's. So a to the 4th, b to the 7th. Okay, simplify. So when we have exponents to other exponents, we multiply them. So we get c to the negative 4th, d to the positive 2nd. So d to the 2nd power is fine, but c to the negative 4th, we don't like leaving negative exponents in our final answers. So this shifts to the denominator. So that becomes d squared over c to the 4th. Okay, simplify. So we've got a square root symbol here. So we're going to look for anything squared we can create inside the parentheses. 24 can be split into 2 squared times 6, because that's 4 times 6 is 24. X cubed can be split into x squared times x, and y squared is already squared. Okay, so taking things outside, I take the 2 outside. The 6 stays inside. I take this x outside. There's another x left over inside, and I take this outside. So 2xy on the outside, radical 6x on the inside. Okay, so I'm looking for a cube root, so I want to create things cubed inside. Okay, so let's see. 2 cubed is 8. Oh, but 4 cubed is 64. Okay, m to the 6th, that's really m cubed times another m cubed. And n to the 5th, well, we'll create the n cubed, and then we've got n squared left over. Okay, so taking things outside, we take the 4 out. We take 2 groups of m out. So we take an m, then another m, so that's m squared. And then we take a single group of n out. Okay, so what are we left with inside the cube root? Just an n squared. Okay, simplify. So both parts get affected. The 8 and the x to the 6th get affected by the 2/3. So 8 is to the 2/3. And then when we have an exponent to another exponent, we multiply them. Okay, so the x part becomes x to the 4th. Okay, how about 8 to the 2/3? We could rewrite that as cube root of 8 squared, which becomes cube root of 64, which becomes 4. Okay, fully simplify. So we can't leave, or we don't like to leave radicals in our denominator. So to get rid of it, I'll multiply both parts by radical 2. So when we multiply radicals, we keep the radical and we multiply the insides. Okay, so radical 4 is regular 2. Radical 28 can be split up into radical 4 times radical 7. So the radical 7 will stay, but then radical 4 is 2. Then 2 over 2 reduces, so I'm just left with radical 7. Okay, fully simplify. So this time I've got a cube root in the denominator, so I got to create cubes on the inside. Okay, my goal is to end up with a cubed. Right now I've just got a single a, so I need a squared to join it. And for the b's, I've already got b squared, so I just need 1 extra b. Okay, then I need to multiply the numerator by the same thing. Okay, so I've got my a times a squared is a cubed, b squared times b is b cubed, and then simplifying the numerator, keeping the numerator the same, simplifying the denominator, cube root of a cubed is a, cube root of b cubed is b. Okay, so to get this radical out of the denominator, because there's more than one term, we need to multiply by the conjugate. So it's almost exactly like the denominator, except you switch the sign in the middle. In this case, it was subtraction, so now I switch it to addition. Okay, so I need to distribute. 7 times 3 is 21. 7 times radical 6 is plus 7 radical 6. Okay, in the denominator, 3 times 3 is 9. 3 times radical 6 is plus 3 radical 6. Negative 6 times 3 is minus 3 radical 6. And negative 6 times positive 6 is minus radical 36. Okay, so simplifying the denominator, I'll keep the numerator the same. So plus 3 radical 6 and minus 3 radical 6 cancel out. And then minus radical 36 is really minus 6. So 9 minus 6 is 3. Okay, we can't reduce this any further because we would have to be able to find a greatest common factor of 21, 7, and 3. And that's 1, so dividing by 1 is not useful. Okay, evaluate I to the 20th. So I to the first is 1, I squared is negative 1. I cubed, if I multiply negative 1 by an extra I get negative I. I to the fourth, negative I times an extra I would be negative I squared. So that's negative 1 is positive 1. Sorry, this is an I. Okay, then I to the fifth, an extra I times the 1 I'm at is back to I. So I see the pattern, the I to the first, I to the fifth are both I. So then you just add 4, it looks like it repeats every 4. So I to the 8th is also 1, I to the 12th, I to the 16th, and I to the 20th. All of these equal 1. Okay, simplify, so we're adding, so we just combine the real part, 3 plus negative 9. And then separately we combine the imaginary part, negative 8i plus 6i. 3 plus negative 9 is negative 6. Negative 8i plus 6i is negative 2i. Okay, so we need to distribute. 2 times negative 3 is negative 6. 2 times 6i is plus 12i. Negative 7i times negative 3 is plus 21i. Negative 7i times 6i is minus 42i squared. Okay, so I can combine these middle two terms. 12i plus 21i is 33i. Okay, so negative 42i squared. Remember that I squared equals negative 1. So it's really negative 42 times negative 1, which switches to plus 42. Okay, and then combining negative 6 plus 42, I get 36 plus 33i. Okay, so now working with imaginary numbers. Just like radicals, I don't like having i's in the denominator. So I'll multiply by I over I, and I'll put parentheses because I need to distribute. I times 3 is 3i. I times I is plus I squared. In the denominator, 4 times I is 4i squared. But I squared equals 1, so this switches to 3i minus 1 over 4 times negative 1 is negative 4. Okay, this is not one of the choices. It's close to these two, but they both have positive 4 as the denominator. So I'll multiply both parts by negative 1 over negative 1. And that turns into negative 3i plus 1 over 4. So that would be choice A. Okay, so fully simplify. 4 minus I over 2 plus 5i. So here I need to multiply by the conjugate because the denominator has multiple terms separated by a plus or a minus. So the conjugate looks like the denominator, but you switch the sign in the middle. So since it started as a plus, I switch it to a minus. Okay, and then I need to distribute. So I've got 8 minus 20i minus 2i plus 5i squared. And then in the denominator, 4 minus 10i plus 10i minus 25i squared. Okay, so I'll simplify the numerator first. So these combine to negative 22i. And then 5i squared is equal to negative 1. So positive 5 times negative 1 becomes minus 5. 8 minus 5 is 3. Okay, now working with the denominator, these middle two terms cancel out. That's the whole point of the conjugate. And then negative 25i squared is negative 25 times negative 1, which switches to positive 25. So 4 plus 25 is 29. Okay, so that's choice C. Okay, find the roots. So I'm going to use the quadratic formula. Okay, so B is 3, A is negative 2, C is negative 9. Okay, so continuing to simplify, 9 plus 8 minus 72. Okay, so I've got square root of a negative. So again, by definition, square root of negative 1 is equal to I. So to take the negative out of the radical, I create the I outside. Okay, then square root of 63 can be split up into radical 9 times radical 7, so that's 3 radical 7. Okay, so this looks like choice C. Okay, Bob found that a certain quadratic has 2 complex roots. When graphed on the real plane, how many x-intercepts does it have? So this is 0, because quadratics have 2 roots. If it looked like this, then there would be 2 real roots. Okay, so we know it didn't look like that because there's supposed to be 2 complex roots. If it looked like this, then there'd be 1 real root. Okay, again, we don't want that. So that must mean it never touches the x-axis. So you can't see the roots on the regular real plane because they're both complex. Okay, so M and N. So 87 and M are called vertical angles, which are congruent. And then 87 and N are called corresponding angles, so they are congruent. Or you could say M and N are alternate interior angles, which are congruent. Okay, find the volume of this shape. This is a cylinder. So volume of cylinder is area of the circular base times the height of the whole thing. Okay, volume of this shape. So this shape is a triangular prism. It is not a pyramid. Okay, we can see that the bases are both triangles. Okay, so area of the base, area of a triangle is 1/2 base times height. So in this case, the base and the height are 9 and 12. Okay, then to get the volume, we take the area of the base and multiply it by the height, meaning the distance between the two bases. So from this triangle to this triangle is 18 centimeters away. So 54 times 18 equals 972. Okay, the figure is going to be dilated by r equals 3 from the origin. Okay, so that means all the points get 3 times farther away from the origin, the center of dilation. Okay, so since we start from the origin, we can just multiply the coordinates. So if a is -3, 1, and we're multiplying by a scale factor of 3, that means the changed version a prime is -9, 3. Okay, two figures are similar, find the missing length. So we can just set up a proportion. There's many different proportions you can set up. I'll say 10 to 15, comparing the short sides, equals question mark over 24. Okay, so I'll cross multiply. 10 times 24 is 240, equals 15 times unknown. Divide both sides by 15. Unknown is 16. Okay, which similarity statement could be used to prove the two figures are similar? Well, we've got side, angle, side, side, angle, side. So that's SAS, similarity. Remember, A stands for angle, S stands for side. We can't use AA similarity because we only know one pair of angles. We can't use SSS similarity because we only know 2 pairs, not 3 pairs. And we would never really use ASA similarity because if we knew 2 angles, we would use AA similarity instead. Okay, so what do we know about rectangles? Okay, so is it true that NKM is 50? No, it's not, because we know that rectangles have right angles. So if 50 of it is right here, then the other 40 degrees would be over here. Okay, KJL, so do the two diagonals intersect in a right angle? Okay, so just looking at it, you can tell that this is not a right angle. So if you're not sure, it's always good to draw like a very exaggerated, so I'll draw a very long, skinny rectangle. So now when I draw on the diagonals, it's even clearer that the diagonals do not meet in a right angle. Okay, so if NJ is 5, is JL 5? Yes, the diagonals bisect each other in a rectangle. And is KM 10? So I already know NL is 10. Is the opposite diagonal equal? And yes, it is. Okay, so only 3 and 4 are true, meaning choice B. Okay, so given this rhombus, which of the following are true? So I'm going to draw a very exaggerated rhombus. So remember, a rhombus means all 4 sides are equal. So DL equals LM. Are the sides equal? Yes, that's the definition of a rhombus. DM equals PL. So does this diagonal equal that diagonal? For this picture, it's hard to tell. So I go to my other rhombus, and I can clearly tell that this diagonal is longer than that one. Okay, so statement 2 is not true. Measure of DOL is 90. Okay, so looking at both pictures, it looks like it does appear to be 90 degrees both times, the angle created by the intersection of the diagonals. Okay, and is measure of DLO equal to measure MLO? So basically I'm asking, does the vertex angle get bisected, cut into 2 equal pieces? And yes, it does. So 1, 3, and 4 are true. Okay, the 2 lines pictured are parallel. What are the values of x and y? Okay, so we can set up proportions here. So I'll say 36 compared to 36 plus 24 is 60 equals 48. Actually, I changed my mind. Okay, so instead of using the entire side, I'm allowed to use this little extra section. And then the reason I do that is because when I switch to the other side, for my denominator, I can just pick the extra section, which is x. Okay, so I'm going to reduce this to make the numbers easier. 36 over 24. If I divide both parts by 12, I get 3 over 2. And now cross multiplying, 3x equals 2 times 48 is 96. Okay, so x is 32. So I can get rid of these answers. Okay, so now to get y, so I need to compare y to this 42. So 36 to 42, this time I'll take the left side and the base of the small triangle. So I need to compare this against the left side and the base of the big triangle. Okay, so the left side of the big triangle is 36 plus 24 is 60. And the base is the unknown that I want to know. Okay, so cross multiplying, we get 36y equals 2,520. And then dividing both sides by 36, we should get y equals 70. Okay, what's true about this diagram? So measure of ADE, is this 65? Yes, because, well, it actually helps to do statement 2 first. So it's true that DE is parallel to BC, right? If we just think about it, if the left side gets cut in half and the right side gets cut in half, the line must go straight across, right? Otherwise it'd be something like, if it went like this and it wasn't parallel, then it wouldn't cut both parts in half. So that's how I know this one's true. And since they're parallel, these are corresponding angles, meaning that they're equal in measure. Okay, so BC equals 16. This is true. The base is double the length of the mid-segment. And triangle ADE is similar to triangle ABC. This is true. They both the small and the big triangles use angle A. So I can use AA congruence to prove they're similar. So all the statements are true. Okay, so similar triangles. So Joe is 6 feet tall. He's standing 15 feet from the mirror. The mirror is 2,460 feet away from the Eiffel Tower. What is the height of the Eiffel Tower? Okay, so I'll just set up a proportion. I'll say Joe's height to his distance from the mirror equals the Eiffel Tower's height over its distance from the mirror. Okay, so cross multiplying, and then you divide both sides by 15 to find that the missing value is C. Okay, so a tree is 64 feet tall and it creates a 20-foot long shadow. At the same time, how long is the shadow created by a 112-foot tall building? So I want to know the length of the shadow. So I'll set up a proportion. I'll say tree's height to tree shadow equals building's height to building's shadow. Okay, so cross multiply. And then divide both sides by 64 to get x is 35. Okay, so if AC is 12 feet and BD, AC is 12 feet, and then BD is 8 feet, what's the area? Well, I see from this markings that this is a rhombus, and rhombus has a special area formula, 1/2 times diagonal 1 times diagonal 2. So in this case, diagonal 1 is, doesn't matter which one we call diagonal 1 or 2. I'll say this is diagonal 1, which is 12. Diagonal 2 is 8. So 6 times 8 is 48. Okay, so this last question, it says it's a square prism. So square prism is not necessarily a cube. It just means that the two bases are both squares. So here's an example of a square prism. And the base side lengths are 6. Okay, so area of the base then, area of a square is side squared, so 36. And I know that the volume is equal to area of the base times the height. The volume is given as 468. The area of the base I already know is 36, and the height is my unknown. So dividing both sides by 36, I get that the height must be 13.